Okay, welcome everyone to the Deep Dixie Contest Club is welcoming you to our presentation tonight on presented by Steve Nichols, who is coming to us from the United Kingdom. And so I want to issue a welcome to all of the members of various clubs. And as you'll see on the screen there, a lot of clubs from throughout the United States and Canada particularly are joining us. They've been invited and you're welcome to join us. And I can't get all the club logos on here, but in the bottom right corner, you see one from the Norfolk Amateur Radio Club. And this is a new friendship that we've had, and we're very pleased about that, with from Roger Cook, who contacted us, and then we made friends with Jim Bacon, and now tonight we have Steve with us. Just a couple of announcements. We know this contests are coming up soon, and this coming weekend, as I understand, is the sideband version of the 𝗟𝘂𝗋𝗀𝗀𝘀𝗀 sweepstakes. I boast with the fact that my microphone is still in a cardboard box, and so I think Ron, 𝗣𝗿𝗶𝗴𝗁, is going to help me figure out my settings so that I can actually talk on that fancy radio out in the garage out there. But the also CQ Worldwide CW is coming up, and we really look forward to that. And I know there'll be other ones. The Deep Dixie Contest Club has a spreadsheet with a lot of ideas for future presentations. And if any of you, whether you're Deep Dixie Contest Club members or not, are encouraged to let us know of any ideas you have for programs that might be of interest to the general public. We don't have any programs specifically scheduled for our next presentation, which we've been having every other week. We have a couple of ideas, and I'll just let you know that I've invited 𝗟R𝘁𝗶𝗀𝗁𝘀. Perhaps some of you were here when he did his presentation on the RS-232 serial servers. It was a very well received program. The man is brilliant. And he also does one on automating your shack. And so shack automation, I think that would be one that would be interesting. And a local ham here in Tupelo, Mississippi, birthplace of Elvis Presley, is Chuck Moffett, N5 Victor Golf Kilo. And Chuck has had a great bit of experience with VNAs. And since we're so close to MFJ Enterprises, and Martin is a good friend of ours, Martin Jew, he's done things with the MFJ VNA, and he also has a couple of other types of things. And perhaps some people who might watch this program or be with us in the evening have never used the VNA or really don't know what it does and what its capabilities are. So that's something that we're thinking about too. We have a lot of other ideas. So we hope to announce something soon. If it's okay, I'll be sending out that information to the various clubs. We do plan to record this program tonight. We're recording it right now. And when it's completed, then we'll go through and post that on YouTube and send out the link back to everyone and all the clubs who got this notice, so that you can come back and watch it if you want to get reinforcement, or if you have a person who's a friend in your club who didn't get this, and we'll let them kind of catch up on that. So we'll let Steve talk some more about the area of the world in which he resides and so forth. But it's basically in that bottom kind of southeast. We like southeastern things, like John McVeigh and I live in, and Ron live in the southeastern United States. So southeastern United Kingdom, I guess, is a good place to live. So tonight we are thrilled. We are so honored and privileged and excited to have Steve Nichols, who has agreed to join us to present the program on propagation prediction tools, the latest propagation prediction tools. And his call sign is G0KYA. So just to let you know that Steve does a lot more than just sit around and have good ideas. He does populate the printed document with these, and these are just some of the books he's written, and they're available through the Radio Society of Great Britain, RSGB, as well as ARRL. And he writes about other things too. So if you want to, you want to know how to make some money, you get some secrets of success from him. So in your when you get through, you just might want to pay attention and go back, if you haven't already, and check Steve's blog, the G0KYA.blogspot.com. There's some outstanding information there. So without further ado, I'd like to issue a warm Deep Dixie Contest Club and U.S. welcome to Steve Nichols, and take it away, sir. She's all yours.
Thank you very much. It's a privilege to be invited by the club to give a talk here. Just want to make sure that you can actually see this presentation slide before I start talking, so I know there can be a delay before it comes up.
Great.
Looks good to me.
Yeah. Oh, good. That's brilliant. I did one the other day, and it took about 2 minutes to appear for some reason. We don't know. Okay. Right. Let's get going. Well, basically, as I'm Steve Nichols, G0KYA. I'm the chairman of the RSGB's Propagation Studies Committee. Doesn't mean I'm an expert. It means that I have to corral everybody else to who are the experts to do stuff for us. And it suddenly dawned on me recently that we've now got a number of tools that we developed over in the UK with help from amateurs around the world that people probably don't know about. So I thought it was a good opportunity to have a look at the tools that we produced and show you how you can use them. So the final slide will be a list of URLs that you can access to get at some of these tools. But without further ado, I think we'll get on with it anyway. I think the first thing, oh dear, right, okay. That's a good start, isn't it? There we go. I think the first thing to do is really say, well, where are we in the solar cycle and what can we expect to come? I think it's always a good start. And basically, if you didn't know it already, we are at minimum. We're at the 2020 down here. We are just past minimum, actually. Minimum, I think, was defined as December 2019, although things didn't really start to get going again until about June. And we are only now starting to climb up the curve of solar cycle 25. We have had some better conditions. I think the flux has been up into the 90s. This week it's been high 70s, and I think, fingers crossed, it should start to improve again. There's a sunspot just coming around the sun. So I think, we should start to see some more activity. And beyond that, I think we should see the cycle pick up quite quickly. The solar cycles tend to get going. Once they get going, we climb up the sharp end of the curve quite quickly. And also, you can see there the prediction, the consensus prediction on what solar cycle 25 will be. The consensus seems to be that it will be similar to solar cycle 24, which wasn't actually that dynamic. No sooner it started, it finished, really. But there've been talk of, will we have a Maunder minimum? No, I don't think we will, as we'll see later. And in fact, there was something out from the ARRL today, another study that's just come out saying that solar cycle 25 could be the best for many, many cycles, which I find that hard to believe, but I think you will have to see. The only way I think you ever know what the cycle is going to be like is once it's passed. Just like you never know when you're at minimum till you've gone past it, and we are definitely past it now, and we're climbing out. So that's good news. So this is just a plot. As you can see, solar cycle 24 wasn't terribly good. Double peaked, actually, if you notice that. It's characteristic of all cycles, actually, that you tend to get the sunspot maximum in one hemisphere, slightly different time to the other. So you end up with this double peak. But yeah, let's hope that cycle 25 can be a good one for us. Okay, this is 400 years of sunspot observation. And you can see that you know, it's been a mixed bag. It's right the way back to 1750 or earlier. We had the Morn minimum, you know, in the 1650, 1700 period, and we had the Dalton minimum around about 1800. It's hard to see a trend when you're looking at this. I mean, the way I think of it is the sun has been shining for millions of years, and we've only got, you know, maybe 400 years of sunspots. So it's really hard to actually, you know, know what's going to happen. But there we go. So in other words, we don't really know. But what tools have we got that can help us? The consensus really is that we're not dipping into another Morn minimum. That's the first point. And that the current weaker magnetic field strength also means that we're getting higher cosmic ray flux through this minimum phase, which can enhance radio propagation. The cycle is slower, lower luminosity, lower activity at maximum, and consistent with a downward trend exhibited since the peak in cycle 22. And the minimum was in December 2019, although the minimum just continued really, as I said, into 2020. And as I said, cycle 25 may be similar to 24. That is not outstanding, but there's a possibility of extreme events during these weaker cycles. So who knows? We'll have to just see. And this is just to remind us, this is what the sun looks like in extreme ultraviolet today, roughly today on the left. And in 6 years' time, this is what we might see, you know, more of a boiling mass of plasma, really. And I think one point I would like to make is that fast solar wind from coronal holes has been the dominant disruptor of propagation and continues to be so. I mean, coronal holes are areas of the sun with open magnetic field lines, lower energy parts of the sun. So if you look at the sun in extreme ultraviolet, you see these black spots on the sun, and they have, you know, have been rampant over the minimum period and continue to be so. And I think this next week, we've got another coronal hole coming around the sun, becoming Earth facing, and that can cause problems. On the whole, coronal holes, not terribly good for propagation. We generally find that they lower the maximum usable frequencies, but you can sometimes get a pre-auroral enhancement. So you have to look out for those. They don't last very long, but it's the sort of thing that can make 10 meters come alive for a couple of hours, 3 hours before the main plasma hits, and you know, then generally the effect of a coronal hole, or the plasma from a coronal hole, is to deplete the ionosphere and the MUF goes down. And we just mentioned something there. We said looking at the sun in extreme ultraviolet. Where's the easiest way to do that? Well, solarham.com is probably the best place to go. And you'll see there, I click here on one of those images. The top left-hand image is the sun in visible light. And the one next to it with the arrow pointing to it is the extreme ultraviolet view. And that's the one that shows you the coronal holes. You know, so that's where you can find, if you click on that, it will enlarge it up. You can actually see. And I think it's important to see the sun in extreme ultraviolet, so if you're trying to work out what conditions are going to be like. For example, this is an image from solarham.com, and the sun rotates basically left to right here, as you can see, directed by the arrow. So you see these coronal holes moving around the sun. And, you know, how do we know when the material is going to hit the Earth, which is the important thing? Well, basically, as you watch it, it will rotate, continue to rotate. So that the coronal hole mark 64 there. The next day, it will probably be sort of Earth-centric, and then it takes a couple of days for the material to actually hit the Earth. And we look at that now. So if the sun is 149.6 million kilometers from Earth, and we know the speed of the solar wind is somewhere between 400, 800 kilometers, if we do the sums, it means that if the solar coronal hole is Earth-facing, we can expect the plasma to hit in about 2 to 4 days. It's really hard to be precise because we don't know how fast it is until it gets here. But on average, that's 2.1 to 4.3 days. 2 to 4 days is probably roughly it. Coronal holes, solar wind speeds are not phenomenal, not as bad as a CME anyway, but they're fast enough to cause some problems. Anyway, that's a quick sort of overview of where we are in its solar cycle, and just a little bit about coronal holes as well. Other thing is, obviously, the material of a solar coronal hole, when it hits, pushes the K index up. And somebody was saying to me the other day, well, which K index do you use? Because there seem to be so many. Well, basically, we take the KP index, that's the one we use anyway, the planetary K index. And that's an average, basically, of the College, Alaska, Fredericksburg, and Boulder, Colorado K indices. And it's probably, if you look at the college one, which is, I think, Alaska, isn't it? I think you'll see that it's quite peaky, you know, it goes up a lot higher than the one in Boulder, Colorado. And it's obviously because it's a lot further north. So it's the KP index, the planetary index we need to really look at to work out, you know, whether conditions are going to be good or bad. And obviously we want low K indices, which we've had this week, actually. We've not had a particularly high solar flux index, but we have had a low K index. And I think that's, you know, the ionosphere has reflected that. It's been quite good conditions this week. So let's have a look at some of the tools that are available and what we've done with them to make them easier. This is an ionosonde plot, or a digisonde plot, from the Chiltern ionosonde in the UK. And from this basically an ionosonde fires a radio wave straight up and sees what comes back down, and it sweeps up in frequency. And you can see that across the bottom here, that's in megahertz. So it goes from 1 to 15 megahertz. And we get the return image, or the return signal, and we can plot it and we can see how high things are. So from that, we can see that the F layer is around about 250 kilometers, and it goes up, and then there's nothing else. Basically, there's anything above about 6 megs there is going straight up and straight out into space. So it's a very useful tool, and from this we can extrapolate the maximum usable frequency over different distances. So from this plot here, we can extrapolate that we consider the 3,000 kilometer distance. The MUF would be about 19.2 megahertz. So these are useful tools. They show us a number of things. They show us E layers, they show us sporadic E, they show us the maximum usable frequency. It also shows us the splitting between what we call the ordinary and extraordinary wave. Any radio wave that goes into the ionosphere gets split into what we call an ordinary and an extraordinary wave. And the extraordinary wave is always a little bit higher in frequency than the ordinary wave. So you can see the red split, or the red image there, and the green image or plot there. One is slightly higher than the other. That's the difference between the ordinary and the extraordinary wave. So when we're talking about critical frequencies, we need to define what we're talking about. Are we talking about the ordinary or the extraordinary wave? And we generally talk about the ordinary wave as being the critical frequency. But it does mean that, in fact, the critical frequency is a little bit higher than the quoted critical frequency, but only for about half of the energy that's pumped up there. But the point I was trying to make about this is a digisonde plot, and it's very useful. Lots of useful information on there, but it's a bit tricky to read. To any newcomer trying to look at that, can't really make much sense of it. And also, if you were trying to see how the day was progressing, you've got to look at one of these every 15 minutes. And this was the first tool that we produced. And it's Jim Bacon, who you had a chat from last week, actually thought about doing this. And we talked about it, and lo and behold, he's got a program he worked with at WeatherQuest, the company he was the director of, who actually came up with it. And this is the tool that they came up with, or they invented, propquest.co.uk. And as you can see, what it does is it takes the critical frequency information from the Rutherford Appleton Laboratory digisonde and plots it for the whole day. So you can see across here now that from midnight in the UK, midnight UTC, the critical frequency is relatively low, and it kind of tails off until sunrise. But as we hit sunrise, the critical frequency rises quite quickly and peaks about midday before tailing off again. So what we can see here is at the bottom, we've got the MUF, we've got the critical frequency. And then we've got different colors which show us the maximum usable frequency over different path lengths. So the top one there is the 3,000 kilometer maximum usable frequency. Then we've got 1,000 kilometer, 500 kilometer, and 100 kilometer. So you can easily see this, look at this without even turning the radio on, and you can see whether conditions are good or bad and what bands you're likely to work. So on this particular day here, you can see that over 3,000 kilometers, the MUF gets just above 18 megahertz. So the likelihood of 15 meters and 15, 12, and 10 meters being open would have been pretty slim. So it's a useful tool. It also shows you if there has been a solar flare, because the graph just disappears. There's no information. So this is one of the tools that we developed in the UK, or Jim has developed really, and it's called propquest.co.uk, and you're quite welcome to use it. And it's a useful tool for seeing how conditions are. And today I think I checked, and the MUF has been up to about 21, maybe touching 24 megs as well. So I think that's just another sign that things are improving. So PropQuest was, as I said, was Jim Bacon's idea, but he's developed it, and it's free to use now, and we quite like what he's done with it. Also, you get to choose one of 3 different ionosons. You can go for Chiltern or Fairford in the UK, or Daub, which I think is Belgium. So if one of the digisons is down, you can always use one of the others. It's an interesting point as to whether we could include an American digison on there. I don't see any reason why it couldn't be added. And if you guys are interested in it, we could maybe talk to Jim about having the option to put one of the US digisons on there. So you could actually have just click on the on that, and you could have critical frequency and maximum usable frequency for the US, because it's obviously very UK centric at the moment. And another thing that Jim has done is he's just plotted there the FO/F2, which is the critical frequency of the ordinary wave, and the critical frequency of the FOES, that's the sporadic E layer, and spread F critical frequency as well. And that's this is just added recently, so that this is very useful if you're doing work on near vertical incident sky waves. If you're trying to use 80 meters to work around the US, you know, you can see whether it's going to work for you or not. In this instance, you can see that what we got FO/F2 is a round about 4 megahertz there. So 80 meters would probably be a good band to work local stuff. And as you go up in frequency, you get a little bit further. But if you want to work local stuff, you're going to have to be using 4 meters. So again, these were tools that were introduced so that we can actually look at them to see, and we actually do, you know, propagation predictions and propagation forecasts for how conditions are. And you don't even need to turn the radio on, we just do it from these. So it's a useful tool. But as I said, if you're interested, I don't see any reason why we couldn't include another a digison from the US on there, and you could select that as well. Anyway, moving on. Another thing that Jim did is he has sporadic E. He's a weather forecaster. If he told you last week, he was a meteorologist, professional meteorologist, and he has been working on sporadic E propagation for some time. And one of the factors for sporadic E is jet streams, and jet streams that pass over mountain ranges. So from May to August, we have this part of the PropQuest as well that has he does a daily blog, or it might be a weekly blog actually, on there, and commenting on whether he thinks sporadic E would be good or bad that week. And then using these plots, he can actually you know, indicate where he thinks that sporadic E would be working. So that's another thing that he's done in the UK, and I'm sure he'd be more than happy to talk to, you know, anybody who'd like to take this on in the US as well. Then take it a little bit further, he's just launched something called the EPI, the E's probability index, and this is a beta version of it that I took the screenshot in September. And this is going to be brilliant, I think. It's going to show you in real time or near real time, you know, the probability of propagation, sporadic e-propagation from the UK anyway, to various parts of Europe and beyond. This is basically working on, it's kind of an improvement on the other work that he did on sporadic E. But this should be really, really good. And this has been put in place and finished, so it's ready for the sporadic E season to start in May in the UK. Although there is a minor season coming up just after Christmas as well. So we're going to have to see whether it works. And the thing is, it's in beta, so we're just seeing, and it works quite well if it suggests that it thinks there will be you know, good conditions down to France, south of France. On the whole, yes, it's right, but you know, this and the color will you know, will go from very poor, which is sort of blue, up to yellow and red. So this is the first time, I think, that we've had a chart like this that can actually be used to predict sporadic E directions in Europe anyway. So this is PropQuest, as I said. Other tools that are around, reverse speaking network. I think you're probably all aware of what reverse speaking network does. If you're not, I'll just let you know that every time you send out a CQ on CW on one of the bands, you do CQ, CQ, CQD, G0KYA. There's skimmers all around the world that will pick your signal up and put it on the reverse speaking network. What we did is we used that, automated it so that it looked for signals from certain places. So this is signals from the ER16 beacon in Europe that was received in Germany. And this was something that was done about 6 years ago as a study I was doing. And it shows you quite clearly that the sporadic E season starts in May, sort of mid-May, and continues through to August, but it tails off. You know, we had a really good start to the sporadic E season, then you can see it tails off until you get the odd day when there's nothing, obviously, but you know, it shows you. And what we were trying to do is we were trying to tie into meteor showers, because there is a thought that meteor showers seed sporadic E. Basically, the ionized material from meteors is the fuel for sporadic E. And then it's wind shear that then brings the stuff together to cause the ionized layers. I don't know if it really proved anything, to be honest, but as you can see, we've put the top, the green parts there, show the meteor showers. And there's obviously a good sporadic E opening there on the 4th of July. There were no meteor showers, so I don't know if we proved anything or not, but it's another good tool that we used to do that. And you can do this yourself, because you can access the reverse beacon network data and just pick 2 points and plot it and see how it goes. But I did this for some 6-meter beacons around Europe, and you know, we wrote it up for Radcom, which is basically the equivalent of it's QST, isn't it? I think the ARRL magazine.
So Steve, may I interrupt you a moment?
Yeah, of course you can. Yeah.
Okay, we have a question from one of the viewers, John NN5O. Says, is the wide range E's prediction like US to Europe or US to Asia?
The plots that we did here were just for Europe. The thing is that E's, multi-hop E's, is a little bit harder to predict because you need to have the hops going in, multi-hops in one direction. And that's pretty hard to do. So the predictions that we're doing are single hop for Europe and Europe only at the moment. I think to actually get it to multi-hop would be a tough one for Jim to do, to be honest.
Yeah, well, the message that I get from what you showed is that it's amazing that such of those tools have been developed, and it might be an instruction to perhaps someone who wants to create something US-centric to sort of tie into that. So I hope that helps. Thank you.
Yeah, sure. Good.
Move along.
Yeah, okay. Just to look at some of the other tools that are available. This is a chart really of the tools that are modes that are available and the general or relative sensitivity of them. At the top, you see the speech, 10 dB signal to noise ratio, or required signal to noise ratio to do it. Come through CW from 0 to -15 SNR. You've got to be a pretty good operator to work at -15 dB, but there you go. Through 𝗣𝗍𝗶𝗴𝗁, Psk, and then right the way down to FT4, FT8, 65, and Whisper. This is just show you why Whisper is so fantastic and works so well with milliwatts. It can work down to -31 dB SNR, signal to noise ratio. But there we go. This was the Propagation Studies Committee stand that we had at the Newark Hamfest in 2019. The event didn't take place this year due to COVID, but I include this because I think it's quite interesting. One of our members suggested that, or he asked really, could we put a Whisper station on at the show? And I said, what would be the point? I said, it's basically in a Faraday cage. I mean, it's a metal building with a metal roof. I said, it's pointless. So he said, well, no, I want to try it. So he had this tiny little antenna, about 3 foot long, sort of an outbacker type thing. And I think it was running on, well, we'll see in a minute. Anyway, he set it running and I said, I don't think you'll get anything. It's like a Faraday cage. And this was the chart we got. So this was 20 meters. And we were surprised that, you know, with Whisper, it's such a fantastic mode that even running 10 watts in a Faraday cage, we were able to cross the pond on about 4 or 5 different occasions. So this is another good, I mean, Whisper is a fantastic tool for plotting, as is FT8. I mean, tools like Psk Reporter show you exactly, you know, where signals are coming from at all times. So I thought I'd just mention that Psk Reporter and Whisper are obviously fantastic propagation tools. I've done some work on animating Whisper contacts to try. What we're trying to do is see whether we can actually find this pre-auroral enhancement period and work out exactly when it is, so that we can actually then say, well, yes, it's going to come and it will be about 1800 hours or whatever. But it's work in progress. It's taking a lot of time. But this is just to give you some idea of what this kind of stuff we do over here anyway. Other tools that you can use, cluster and reverse beacon network. I've mentioned RBN earlier, but this is, if we've never seen it, this is the RBN on the right there. So a simple CQ, D and your call sign, and then you see where you've been picked up. I think, I think most people are probably aware of it now. It doesn't have to be CQ, it can be test D, __, your call sign as well. But the other thing is if you have to move frequency, if you're comparing antennas, say, you have to do one CQ like that, then you have to move a couple of KCs and do it again. Otherwise, it won't record you for, I think there's a 10-minute period or something when it won't register you. So if you want to do back-to-back tests on antennas, just a little trick is just to move the frequency a couple of hertz or a couple of kilohertz up and do it to send it again, and then you'll get another set of results. So it's a good trick for that one. Club log. I don't know how many of you are familiar with club log, which is a UK invention, really, that is fantastic. I mean, rather than working out the likelihood of being able to contact Alaska from the UK, for example, club log's propagation approach is to say, well, what have we actually got? What have we actually logged in terms of QSOs? Which is another way of looking at it. But if you're trying to work out the best time to work from one place to another, well, rather than look at the propagation prediction charts, is actually see, well, what have people done in the past? So this is a great tool, and it shows you there that if you wanted to work on, work UK to Alaska, which I do for my Work to All States award, You know, if look at that, we've got 30 QSOs on 40 meters. Is that 19 on 30, 19 on 20? So it looks to me that probably the best bet there is maybe 40 meters, and around about 7 o'clock, 1900 hours Zulu looks like the optimum time to do it. So it is a great way, and it saves you, if you're doing point to point, it saves you wasting an awful lot of time trying to make contact when you don't stand much chance at all. So that's club log, which is a totally different way of looking at propagation predictions, in that, you know, instead of saying, what do the charts say? What do we think might happen? This is saying this is what actually does happen. And Psk Report I mentioned earlier. This is a great tool. You can pick up whatever band you want and see which one of these blobs is been hearing what. I mean, I run this every day from my QTH, and you know, you can see exactly what's going on and where, and you get some very big surprises, especially with FT8, because it's so sensitive. So again, from a propagation tool, things have changed so much. You know, the old days, it was, you know, you ran VOACAP on your computer, or 𝗨𝘀𝗶𝗴𝘁𝗀 on your PC, and you had a load of information that was, you know, a best guesstimate of what conditions were like. Now you can actually see in real time where things are working. And really, these have all come about in the last 10 years. And it's only when you start thinking about it, how these things could be useful. You know, you can do an awful lot of decent research work with tools like Psk Report. Now, this is where we go into things like Proppy and Predtest. I've got to tell you this, where it all came from, though. I mean, every month, Radcom in the UK, which is, as I said, the RSGB's monthly magazine, has a chart, propagation chart. We've had that in there for years and years and years. And basically, it's propagation from the UK to 26 different locations, I think, around the world. And it just gives you a color as well as a number. And the number is the predicted S unit for your signals. And the color goes from red and blue, depending on the probability of making that contact. Now, this looks pretty ropey. This is because this is July 19, and this is obviously sunspot minimum. So things weren't very good at all. But the only problem with this is Gwyn Williams, G4FKH, is on propagation studies committee with me, and has been doing a grand job running us for years. But every month we would get complaints saying, well, look, you know, it says here I should be able to contact the Canary Islands, and I can't, you know, I can't work them. We say, how much power are you running? 10 watts. What sort of antenna are you using? Something pretty dire. And at the same time, we then get someone else saying, well, this is ridiculous. You know, I can work New Zealand every day. You know, it's predicting there's hardly any propagation there at all. So you're using a linear? Yeah. And you've got a 3-element stepper at 100 feet? Yeah. And so the trouble is, this was always based on 100 watts to a dipole. And so we've always had this in Radcom, but it frustrated me beyond belief that some people will do far better than this. Some people will do far worse, depending on your situation. But these are monthly median figures for what you could work from the UK. So we took this model and then thought, well, what else could we do with it? And so we developed it further into VOACAP charts for Radcom. And this was work that was done by 𝗟R𝘁𝗶𝗁𝗀𝗄𝐺 in Finland for us. And it was very good, because basically said, look, what we'd like is, we'd love to be able to produce charts on the internet, where you basically say, what is your grid locator? How much power are you running? What mode are you looking for? What's your antennas? You know, and click a button, and then just have your own charts, so they would be specific to your station. And so Yari went away and came up with this. And so now when we run the chart, this is the charts we get. So it looks at 28 locations around the world. 4 of them are with short path and long path. And the rest are just short path. And it generates hour by hour reliability predictions for each band. But it suddenly dawned on me that, well, actually, this works by putting your locator square in as your station. So there's absolutely no reason why you guys can't use it. And I'll show you the URL for you to use it. And this is the charts, or the charting tool that I sent to Larry. And he said, well, it'd be really nice to have a quick guide to what could you work around the world. And I said, oh, that's dead easy. You can do that in about 2 minutes now. So it's VOACAP, and it was coded by Jan. He's done a fantastic job. But we've just made it easier for people to do it. So that was the first tool that we came up with. And it was, as I said, it was the reason we did it was to get around this issue of Radcom's charts being no good for anybody, really. They're an average chart for 100 watts for a dipole, but if you had a better system than that, or a worse system, you know, they weren't really going to be accurate enough. Where this one does exactly what it says on the tin. You know, you say exactly what modes you've got, what antennas you've got, and it will produce it. Now, beyond that, this is where it gets a bit complicated. VOACAP has been a fantastic propagation prediction program for a number of years. But the ITU had been working on another program, which then came out a few years back now, about 5 years ago, which they got a really snappy name, ITURHFPROP. That's the correct title for the program. And so ITURHFPROP came out, and we were looking at it, but it's not an easy thing to use. Basically, it comes out with numeric output, and it wasn't very simple to use. So I said, well, what we really need to do is we need to be able to take this and come up with graphical output. And is there anyone who could do that? So luckily, I mean, Gwyn Williams managed the project at the time, and we were lucky that we had a fantastic program called James Watson, who's in Saudi Arabia, and he did this. So we called it Proppy. It just made it much easier. And so Proppy exists to produce the same output as VOACAP does in terms of Radcom tools. So again, you go into this, you put in your power, your noise levels, your location, and your antennas, and run the prediction, and you get these charts. So it mirrors what VOACAP does, but you will find that the results are slightly different, because ITURHFPROP is a totally different model, ionospheric model. But the debate is, I mean, I think I'm right in saying that Gwyn did some research and thought it was more accurate than VOACAP. I'm going to sit on the fence on that. As far as I'm concerned, it's another tool that you can use. But this tool you can use as well. So again, you put your locator in, and what antennas and modes you're using, how much power, and you'll come up with charts like this. Same locations, by the way, same locations around the world. So it's a very, very quick and easy way of doing it. But basically, Proppy, this is where it gets a little bit confusing as well. James Watson produced the program originally, and then went off and did his own thing, and that is now on a site called soundbites.asia, and it's called Proppy. But Gwyn also basically took what we were left in the UK and produced Predtest, and has developed it in a different direction. So there are basically two different tools now that you can use, Proppy and Predtest, both using ITURHFPROP, but the model that they use, or the output, is different slightly because of the way that they've done it. And this, you know, they are good tools. But this isn't to knock VOACAP at all, and VOACAP Online. No, I mean, again, you used to have a PC, you used to have to run VOACAP. Now you can do it all online. Just go to voacap.com. This is just two of the modes that you can use. I quite like this 24-hour rosette sort of pattern on the left. for working out the best time to work somewhere. So I don't know where this plot was. Is this Norwich to, yeah, UK to New York by the looks of it. And it shows you that you look for the hottest spot. So on 80 meters, 0400 is the best time to do it. You can see the red spot there. So that's a great way of quickly finding the best best band and best time to work places. And again, I think 𝗟R𝘁𝗶𝗁𝗀 is program vocap.com. Okay. And just going back then to Predtest, which I said Gwyn has worked on. So you can, again, specify your home location and it will come up with an area coverage map of the likelihood of being able to work various parts of the world. And this is a 20-meter plot, 12 o'clock UTC in October 2019, with a smooth sunspot number of 3. So again, you don't even have to know what the smooth sunspot number is for that month. It automatically knows it. It goes to a reference document to get that. So again, you can come up with area coverage charts like this for your location. And I think because you can just put your own locator in, it should work for the US as well, as far as I know. Or you can do point-to-point charts. Predtest will let you say, well, this is where I'm starting from, this is where I'm ending from, and this was the sort of chart you can get. So again, this is, I think this is UK to New York, and you can see that the MUF comes up to around about 20, 21 megs, and then tails off as the afternoon goes on. So again, great way of working out the best time to work parts of the world. Just to have a quick sort of example of that. I was in the California QSO party. Someone said to me, can you do some propagation predictions from the UK to California? And my first reaction was, well, good luck with that, because sunspot minimum, it's going to be a tough call. But we're able to come up with a chart. And this is the reliability, MUF and reliability. And you can see the MUF comes up to about 15 megs there. But as for reliability, there's no coloring on that chart at all, because reliability was 0. So some of the tricks you can use is basically bump up the power, bump up the gain. So you end up with something like that. If you say you're using a kilowatt, even if you're only using 100, see some color on the chart. So you can actually see now that we've got this green blob down the bottom there. So at 630 on 5 megs, you've got a sort of a 60% chance of making that contact now. And likewise, there's another little hotspot during the day. So 1600 hours on 20 meters, you've got a 0 to 20% chance of making the contact. But these are all tools that you can use, and I think this is what the point is, to try and get people to start using them, because we use them all in the UK, but there's no reason why they can't be used around the rest of the world as well. And this is FT8. So I'm just going to go back one. So look at the chart there. I think that's a path, from UK to California, and I think that's CW. And then we go to back to the same path again with 100 watts to FT8. And you can see that the probability comes up dramatically. So we've got 70 to 80% chance of making a contact on 5 megs now at sort of 0600, 0630. So again, FT8 is a fantastic tool for working stuff with either low power or poor antennas, really. This was a long path calculation, because that's the other thing, is when you're doing calculations, don't just assume that everything's got to be short path. Try the long path as well. And again, this shows that there is a long path opening to California around about 3 o'clock, 1500 hours on 100 watts CW. No, just while we're talking about some of the other tools around, grey line is obviously important, grey line conditions. And there was a free grey line map at mapmaker.com. There's the URL for it. I'll make sure that you get a copy of this afterwards if you need it. At mapmaker.com, have a free program that you can use, which will show the grey line or the terminator between daylight and nighttime around the world. And that's quite a nice little tool, and it's absolutely free to use for a PC. It's PC only. But how do we use that then? Well, this is a chart of grey line conditions that existed between 𝗨𝘀𝗶𝗴𝗁, breed of the first island in the Antarctic. And we basically took the calculated path with 𝗣𝗿𝘀𝗽𝗋 and then actually compared it with when were people making contacts with 𝗨𝘀𝗶𝗴𝗁 on I think it was 80 meters. And as you can see, it's all those contacts are on the morning side, or as the sun rose in the UK, almost exclusively. And we actually recalculated it for easterly. So the green area is calculated for Norwich, which is where I am, which is in the east of England. And then we found that we recalculated it for easterly, which is it's actually further west than here. And again, you can see that those contacts were made just on sunrise for 80 meters. So it's important to be able to, know when sunrise, when the grey line is coming over either you or the other station to actually work people. And the grey line period can be minutes or seconds, even for top band, can be a few minutes, maybe 15 minutes, maybe for 80 meters, and the grey line gets longer, or the grey line time gets longer as you go up in frequency. So I'm just going to nearly finish now. So this is a great image that I borrowed from one of your colleagues over in the States. Why is HF propagation so complex? Well, I think this really sums it up. There was just so much going on in terms of geomagnetic information going on around the world. If you look at that, you've got all sorts of E-driven downward flows, plasma sphere, draining and heating, magnetic flux tubes. We haven't even talked about sunspots yet, but you get some idea of what you've got to actually take into account when trying to work out programming or production. Sorry, I'm getting tired. I'm starting to lose my words. So in summary then, these are the tools that we've got available for you. So it's all rsgb.org, and we've got PropQuest, which was Jim Bacon's Ionizant plotting tool, and also the sporadic E tool. We've got Predtest and Proppy, which are the two tools for doing those 28 direction propagation predictions to 28 locations around the world. And we've got VOACAP one as well, so that you can do the same thing that 𝗟R𝘁𝗶𝗀𝘀𝘁𝗃 has produced. And then finally, rsgb.org, G0KYA. I think that, from memory, that goes to my blogspot as well. So there we go. So we basically tried to produce as many tools as possible and introduce them and make them widely available. And the easiest way to do that was put them on the internet. And so we've developed those and also make them free to use as well. That was the most important thing. So you don't need to have a subscription to any of these. You don't need to pay for them. And they're open to the people who want to use them. And so if anyone's got any questions, now is probably the best time for the questions. Or if you want to email me later, psc.chairman@rsgb.org.uk is my email address as far as RSGB is concerned. So just open up now to any questions.
We have some wonderful questions. Okay, I'm going to hold my question. Go ahead.
No, I was just going to say, we have a question from Bill, KC4D, and he says, normal QSOs are two-way. Can we assume that the plots are accurate in relative terms in both directions on a path?
Yes, basically. with some provisos. I mean, on the whole, paths are reciprocal. So if they'll work in one direction, they'll work in the other. I mean, there are instances where paths are not reciprocal, but they are, on the whole, I think that they are less common than others. So yes, they should work both ways. Absolutely.
That was great. Maybe, Bill, if you want to chime in, there was a good conversation in the chat room between, well, involving Bill, Kilo Charlie 4 Delta, KC4D, he's up in Virginia, and Tom, KG5RXE. I'm going to assume that Tom is in Texas. And it had to do with basically Bill's question was, and if Bill wants to talk, he certainly can do this. What stations in the U.S. might be appropriate? By the way, let me say that any of us on the program tonight can feel free to chime in on this, because Steve has really sort of prodded us to do something. What stations in the U.S. might be appropriate to provide the necessary data to add a node in the U.S. so we can use these cool props projections? And then Tom follows up, says, I know there are ionisons in Austin, Texas, Boulder, Colorado, and Eglin Air Force Base. Eglin is in Texas, isn't it, Tom?
I think it's in Florida.
Oh, yeah.
Yeah, I mean,
Florida's in East Texas, isn't it?
I mean, there are digisons. Of
course, Larry, it's in East Texas.
There are digisons all around the world. I mean, I've got a list of them, and it's just a case of finding the right one.
Well, if you could publish that to us somehow, so we could look at it, maybe we have some connections at some of those where we could have some influence to make them available to you. I mean, that's what I'm trying to get at here, you know, because I don't know why anyone would not want to share the data with you for the benefit of the larger population here. So yeah, please let us know, and we'll try to see if we can pick one out and help grease the skids, if you will.
Yeah, I mean, basically I think Jim gets the data from one source. I can't remember the name of the source now, but basically the Digison data for all around the world is fed to one central repository. So I don't see any reason why you couldn't get it. I think it's just a case of nobody's asked us to it yet. So
can we officially consider this an ask, and then let us know if he has any problem getting the data that he needs in the U.S., and we'll try to intervene for him if necessary. I mean,
yeah, okay. I will email him tomorrow and say any chance that we could include another Digison on there. I mean, we've got the three at the moment. I don't see any reason why we couldn't add more.
Let me just ask you something. Would it make sense to have one on the East Coast, one in the middle of the U.S., and one on the far West Coast and so forth? Because we've got 5 time zones here, or 4 at least anyway.
Yeah.
And I'm just wondering, it would vary some, across the breadth of the United States, I would think.
Yeah, I think it would.
Well,
absolutely.
All the more reason to give us some list, or let us know if he can find 3 consistent spots that he needs, and if he has any problem getting them. So let us know. We'll see what we can do.
Yeah, I mean, the work has been done. The hard work has been done for Predtest now. Sorry, PropQuest. The names get to me. They're all very similar, but PropQuest. And so I think to just add another Digison to it wouldn't take much to do. It's hard. Yeah, I'll take it as a yeah. I'll have a word with him. Jim only lives about 10 miles away, so I can speak to him on 2 meters. So yeah, I could bring it up with him tomorrow.
You said relative terms on a bidirectional path and so forth. You could run the thing looking from the other direction, I guess, with whatever the power and transmitter and antennas are at that direction, and give some idea about how he would be hearing, or what the chances are he could hear people in the other direction. But I think the timing, that's the key thing. If you look like, well, the best opportunity is between 1600 and 1700 GMT or something, it's probably going to be the best on a relative scale at that same time. Is that a fair assumption?
I think it's absolutely right.
In both directions.
Yeah.
Okay.
I mean, there are examples, there have been examples of one-way propagation, but I don't necessarily buy it. I don't think it happens very often. Most of the time, I think it's more to do with local noise levels.
That's why describing your
hear me.
station and your noise levels is so important, I think,
Yeah,
because my
yeah.
issue, here is receive noise. I mean, I'm heard all over Europe on top band with big signals and so forth, but I've got such a high noise floor, I just have a hard time hearing Europe,
Yeah,
except the stations that are very strong. So it makes
yeah,
a giant difference in terms of your capability.
yeah. Well, I've just moved house about 3 months ago, and at the moment, basically there's nothing else around me. I say at the moment, there's actually a building site next door where they're putting up a housing estate, but we knew about that before we even moved. But at the moment, I'm just astonished because I lived in the middle of a housing estate before, and my noise levels were just massive, and I'm hearing stuff that just didn't even realize was there. But yeah, it's not going to get any quieter. That's for sure.
Just a little node to that. Many of you, I understand, were talking about the 7Q7RU group that's over in Malawi at the station that
Yeah.
we started several years ago. And that last night they did over 400 Qs on top band. They had to move from the hospital location out probably half a mile or more, or maybe a mile, to get away from the noise there in the hospital complex and so forth. And now, where they were being heard great from the hospital complex, now they can hear the other direction. So
Yeah.
there's a
Yeah.
good example of where it makes a big difference in terms of,
Yeah.
of the local ambient noise level.
Oh, absolutely. Yeah. With the tools that we produced, I mean, we've made the noise level quite an important factor. So you can actually choose whether you are, and it's defined in the statute as to how noisy they are. But so you can say you are, rural or residential or urban in there. So that helps a lot as well. Yeah,
Well,
noise is the biggest problem.
I'm sorry, I can attest to the fact that Steve and Jim helped me understand something about propagation that's really important. And Bill, it is true that propagation can occur in one direction only, but not the other. And I have examples of that. There have been many times in de-expeditions or contests, I have called somebody and called somebody and and they won't answer. So I know it must be one way.
I wish it was that simple, Larry.
Yeah, I think we all suffer from that. Yeah, that's very good. I like that. Yeah.
There's a little.
Well, do we have other questions while we have Steve on? It's real early in the morning over there at 2:35 a.m. I think. So, but while you have Steve, other questions? There've been some great ones.
We've got a question from Dave NU8A, and he says, Steve, thank you so much for the presentation. Can you comment on polarization effects on HF? Thank you. And he says, what are your thoughts on DX Atlas for propagation mapping?
Okay, let's take the polarization effect first of all. I mean, any radio wave that travels through the ionosphere has its polarization shifted. It can go up vertical or go up horizontal. It will come back circular polarized. It's a case of how circular polarized is it. Basically, we've got one of our members is doing a PhD on this, and I remember we sat around a table discussing it, and we know for a fact that any radio wave that goes into the ionosphere gets split into this ordinary and extraordinary wave, and as they're combined, that's how you get the circular polarization. But whether it's right-hand circular, left-hand circular, or planar, just depends, and it can alter in seconds. So that's sounds like a bit of a fudgy answer, but yeah, to say, oh, I'm running a vertical antenna, therefore I'm only going to hear vertical polarized signals. No, that's not true at all. You'll hear on ground wave, you'll only hear vertical signals, but anything coming from the ionosphere, it's going to be anything. It could be, as I said, left or right hand circular polarization, or planar, depending on how it's traveled through the ionosphere. And this is one of the reasons we get fading A lot of the time, that's the effect of fading. So what you'd probably find is that if you have diversity reception, so you might have a horizontal antenna and a vertical, if the signal is fading on one, it will probably come up on the other. I think it's quite a common misconception that I don't think most people realize that that's actually what happens with polarization. It changes when it goes through the things that go through the ionosphere.
If I may ask, what are your thoughts on DX-Atlas as a mapping tool, propagation mapping tool?
I think it's, I don't use it, but I think what I've seen of it is fine. I think it's very good. And I think you can work DX-Atlas with other programs, can't you? I can't remember what it is that you can work it with, but I know that it will map what you need. I think it's a good program. I'm not using it myself.
And so Ed has asked, and I think we have an answer for him, will there be a document summarizing all of the URLs for the tools discussed? So Steve, to put you on the spot, I would just say that Jim was and had his slides in such a format that he could share them. And I think in the YouTube video description, I was able to put a URL link to his slides, which were a PDF file, I think, that I stored on Google Drive, so that people who watched Jim's recording and looked at the description could click on that and get the slides to that. But what you've done is phenomenal.
I can produce a PDF from that presentation, yeah, and give it to you. That's not a problem at all. I can do it tomorrow, yeah.
So let me throw out another question I've been thinking about. As we contesters plan for the next contest, whether it's here in the US, it's the sideband sweepstakes, or the big one, CQ Worldwide CW, we want to maximize what we're doing. We're excited about the planetary K and those numbers going up. Can you give us a checklist or a menu of things that we should do? And perhaps some of the people listening already know what to do, but maybe what would be the top 3 or 4 things that we would do to just prepare ourselves to make sure that we know when optimum times are to make contacts with various parts of the world, like from here to Indonesia, Thailand, and the
yeah. I mean,
Southeast
basically, propagation prediction programs use smooth sunspot numbers. You don't really want to take the sunspot or solar flux figure or the sunspot number for that day. You need to take the smooth figure. It's been proven that the average figure or smooth figure works best. So you can find that out from a chart today. The reason I'm just pausing is that there's a number of different smooth sunspot numbers now. There's a number of different ways of looking at it. But I would imagine at the moment the smooth sunspot number has got to be down there. I haven't looked at what it is for this month, but it's got to be down there, you know, kind of 2 to 5, something like that. So really you need to look up and use the smooth sunspot number for starters. In terms of the KP index, you won't really know what it is until you get there, because that can change on a daily basis, and that makes a massive difference. You know, if the K index is 5, the MUF is going to be much lower. But this is why we can only really predict up to maybe a week ahead. We get a fair idea. The reason we have a fair idea is because the 27-day rotation of the sun, we know if there's been a bad coronal hole on the sun, and that caused the K index to go high, in 27 days it's going to do it again. So, and also if there's been a quiet period, like this week has been quite quiet, 27 days time, likelihood is it will be quiet again. So that's one way of doing it, is work out when your contest is and look back 27 days and see what conditions are like. It's not a foolproof method of doing it, but it's better than nothing. And I think I said I've just done the GB2RS propagation report for this weekend, and we're going to have disruption. We're going to have problems probably hitting Saturday. So the weekend's going to be, maybe a K-index of 4. It's going to hit quite badly. But I think for CQ worldwide, it's going to then calm down again. So the K-index is probably going to be quite low, beg your pardon. So yeah. So in terms of checklist, what do you want to do? You need to know the smooth sunspot number, because all programs work with a smooth sunspot number. And then you can come up with charts and propagation predictions. You can either feed them into one of the VOACAP or ITURHFPROP tool that we produced, and that will give you predictions for 28 locations around the world. If you want to be more specific than that, you'd have to go and do it yourself in VOACAP.com and say where, and so you basically build a list of charts that show you the best times to work around the world. That's how we do it. We just tried to make it more simple, by just picking 28 locations. Does that answer your question?
Yeah. Oh yeah.
Oh, yeah. Okay.
Yeah. Usually, some of us who are somewhat well, we don't bother looking for our scores at the top of the list.
Right.
We try to provide the foundation for the bottom. We use dice, and flip a coin and things like that. Okay, yeah. So a couple of more things here. Seriously, Dave asks, is there any evidence that the X and O's waves arrive in significantly different geographic locations when there's a big difference between the MUF for each?
Ooh, right. Okay, the MUF, well, basically the critical frequency between the XO and X waves is never more than, I try and remember what the exact figure is. It's never more than maybe 1 megahertz, I think. I don't think it's much more than that. I think the way they, your location and probably your location north or south could make a difference as to how they split. And also how you are firing your radio waves into the ionosphere, that will make a difference. I don't think that it's not really something you need to mess around with too much, to be honest, because it would depend on your location and where you're firing to. Yeah, that would be a tricky one to try and work out, because as you rotate the antenna into a different direction, you need to recalculate exactly what they would do. And on the whole, you're only using that to do NVIS stuff, I think, because once you're above the critical frequency, way above the critical frequency, we talk about the MUF, it's not going to change that much, I don't think.
I think I misspoke, and I meant the critical frequency where there might be a bigger difference. And I asked the question in the context of this question about one-way propagation, and I've wondered if when the wave splits, when the extraordinary and extraordinary wave splits, and that they have this slightly different critical frequency and a slightly critical boundary, physical boundary in the ionosphere, if that might account for this thing that we sometimes see. I
wouldn't have thought so, but yeah, that is something you could open up for. You could actually research it, I guess. Yeah, it's a good question, actually. Yeah, I just spotted another one that's popped up on there. I was under the impression that the K-index is updated 4 times an hour. Is that accurate? The K-index is calculated every 3 hours. And this is the difference between the A and the K-index. A-index is only updated every day, really. It's a 24-hour average. K-index is every 3 hours. So that's the better one to use, because it's more, more timely, as it were. So I don't quite know where you got 4 times an hour from, but yeah, it's every 3 hours. Yeah. And is that from the solar wind generated 2 to 4 days prior? Yes, in a way it is, yeah, because the K-index is influenced by the impact of solar coronal matter coming from the sun. And so, yes, it is generated from the solar wind, yeah. It's not just coronal holes that cause the K-index to go up, it's coronal mass ejections, which have a massive, even worse effect, you know. And generally, coronal mass ejections are linked with solar flares. So as we get more sunspots, be careful what you wish for. As we get more sunspots, we'll get more solar flares, we'll get more coronal mass ejections. So, you know, it's not all good news, you know. But in solar minimum period, we really traded CMEs for coronal holes. And they tend to be linked with solar minimum. So we'll probably find that the effects of coronal holes diminishes as the sunspot cycle goes on. But hell, we will be, you know, at the mercy of the sun as it comes to coronal mass ejections and solar flares. Absolutely, yeah.
You made me think about the days when my brother played with the St. Louis Cardinals baseball. He reminded me that, you know, you don't watch out what you wish for. That along with big home run hitters like Babe Ruth and other people who hit a lot of home runs, you get more home runs, but you also get more strikeouts.
Yeah.
So
very similar.
Same thing.
Okay.
Oh, okay. Any other question that we have for Steve? Okay. Steve, you probably can read the chat. So you see that on the bottom from Mr. Bill. How swiftly does the K index typically change? I was under the impression that the A index was to give you some indication of whether the K index was increasing or decreasing in intensity.
Yeah, the K really defines or drives the A index. The A index is an average. I mean, it's bizarre. They've got totally different scales. So you might have a K index of 5, but that might relate to an A index of, I don't know, 40 or 50 or something. And so it's a bit bizarre. But basically, and it is possible to have a high K index but a low A index because the average for the day hasn't caught up yet. So as I said, it's better to keep an eye on the K index, I think, or KP index, the planetary index, rather than the A, because it's you could be 24 hours out looking at the index.
But it does indicate whether things are improving or getting worse if there's a trend in it. Is that a fair assumption?
Yeah, I think the other problem is that the K index is logarithmic. So basically, you never really see it go much above about, well, at the moment about 6. So the difference between 4 and 6 doesn't sound much. So I think the A index, because it's, you know, it's easier to see a trend, as it were, or see a slight change. Where the difference between, if you had a K index of 3 and it rose to 5, that'd be quite a nasty effect, really, for a 2-point change. But yeah, the A index, I generally don't use it at all now because, as I said, it's generally out of date, as I said.
Well, thank you so much, Steve. Okay. Would get a lot of kudos, pats on the back, and all that stuff on the private chats and what have you. We appreciate it. I think the group here can let me know either by typing something in the chat or send me an email. What if you think it would be of any interest? Steve has done a good bit of work in antenna design, and I know that some of you have built your antennas and arrays. And I don't mean you bought a step IR and put it together and put it on tower. I'm talking about building your own antennas and putting them up, or you know, playing with antennas. Because I know I've heard Steve with his presentations talk about the many antennas that he has put up and tested and tried and played with. And so if you think that some program in the future would be beneficial to that, where we can have not only a presentation but some conversation, I think that would be helpful. I really appreciate, Steve, that you've opened this up to questions and conversation here at the end, because it brings us closer together. And there are a lot of very knowledgeable people, and I don't know if I made it plain at the beginning, but we have people from really big contest clubs all over the country, and we compete against each other in contests, but we're all really friends when the ground gets leveled, and we're just all trying to learn a little bit more. So we thank you a great deal and invite you to come back and join us whenever you feel so led.
Yeah, that's very kind. I mean, just to recap, I mean, the books I've written on stealth antennas are basically they're basically for people who don't have room for masts and beams. And the other book I wrote was on how to use the 𝗟𝘂𝗋𝗄 modeling software. So that might be the one you saw, I think, the presentation on that. So I'm happy to talk about how to use 𝗟𝘂𝗋𝗄 and some of the things that, to watch out for. But in terms of designing antennas, I wouldn't be the best person to talk to about that, I don't think.
Yeah, I think that's right, because I guess the DX commander is the first person I heard say something about that, what you call it, Mama Gal?
I call it 𝗟𝘂𝗋𝗄. I mean, don't quite know, MMANA.
Yeah.
Yeah.
Mama Gal. And then I guess I saw your presentation at the RSGB convention thing where you did some things with that, and that's quite interesting. And I guess I'd been so overwhelmed with the EasyNet things that I didn't really realize that there was something that was somewhat free and online and was easy to play with, and you could do a lot of amazing things with it like that. So that might be something of interest.
Yeah, I think EasyNet is better than 𝗟𝘂𝗋𝗄 in some respects. It's a later version of NEC. I can't remember what the exact numbers now, but for somebody who's starting out or doesn't want to spend money on it, buying EasyNet, 𝗟𝘂𝗋𝗄 works very well. I think that the trouble is that all antenna modeling programs is that you open it up and go, I don't know where to start. So that was the idea, to produce a book that takes you through it step by step. I'll let you into a little secret, actually. It's when I produced the book and it went on to Amazon, the first review was somebody who said, "This is rubbish. It doesn't work. It doesn't work at all. He doesn't know what he's talking about." And I was a bit confused as what he meant by that. So I contacted him, and it turns out he wasn't pressing the enter button. You have to put every line you put in 𝗟𝘂𝗋𝗄, you have to press enter, otherwise it will just disappear. And that's what he meant. So I appealed to Amazon, said, "Can you take that review down?" And they said, "No, we can't." So that basically killed the book dead in the water because one idiot couldn't be bothered to read the book properly.
I feel much better because I had discovered that.
Yeah.
However,
you didn't put the review up on Amazon, did you?
No, I did not.
No.
But I did discover that you better hit enter if you want the numbers to stay there.
Yeah, exactly.
But in trying to follow up on that program and answer questions about how do you insert capacitors and inductors and filters and loads and whatnot, there are lots of questions that don't seem to get answered on the blogs and whatnot. You know, is there a definitive place where that stuff is written down?
Well, I hate to say it, but the book I wrote.
Well, I haven't seen your book, so I can't.
Yeah, it's called Introduction to Antenna Modeling, and it is purely looking at 𝗟𝘂𝗋𝗄, and it shows you how to put.
I certainly will order one immediately.
Yeah, it's only about, I don't know, $10 or something. It's not phenomenal, but it will show you how to include traps, so L and C. You know, coils or traps, and you know, what values to put in and how to calculate the values to put them in as well. So yeah.
Well, the questions come up all over the place.
Yeah.
Many never seem to get answered.
No, probably not. No. Yeah, I got some sympathy with you.
Yeah.
My perception of what Steve has done, at least watching the RSGB presentation, and it's like it's antenna design for the rest of us. Those of us who don't have rooms for 8 towers, but just want to have a small backyard or something. Is it possible even to put up something? And does my inverted V have to be completely flat? If I make an inverted V, no, does my dipole have to be completely flat? If I put up an inverted V, what happens if one leg of it has to be bent. Well, we know that W6SX has done some great stuff for antennas for little pistols, and that's interesting. But Steve has actually played with a bunch of those things and done wound stuff around in the backyard and all that sort of stuff, and it's kind of interesting. So that's wonderful.
Yeah.
I would like to say to everyone that John McVeigh has done a good job of putting in the chat room the URL to our YouTube channel. But let me say, if you can't remember that long URL, if you go to YouTube and you just search for Deep Dixie Contest Club, it will show you the videos that we have posted. And when we stop this recording, we'll have a recording. I will post that on YouTube, and inside that, when we get the PDF from Steve, we'll post that, and we'll put a link to that inside the description. And then I will send an email out, big email blast out to the same avenues that I sent out to notify you for this one. If for some reason you want to make sure that you get these notifications directly, if you drop me an email, then I'll be glad to just add you to the list, the distribution list. And my email address is real simple. My call sign is NN5O, November 5 Oscar. So it's NN5O Larry at Gmail. Or I think you can send it to info@deepdixiecc.gmail or something like that, whatever. But we'll get the word to you if you just remember those long URLs.
Do you have an ARL account, Larry NN5O at ARL.net by any chance?
Yeah, there may be a box up there, but as far as I know, I've never checked.
Well, it'll forward it to you if you set it up to any address you want.
Okay, maybe I should do that. I don't have but 9 email addresses as it is, Bill.
I just spotted that somebody's asked a question about 𝗍𝗏𝗀, saying, is it for Windows only? Yes, it is. But you can run it on a Mac using a program called Wine, Windows emulator, or Linux emulator. No, what is it? Windows emulator, yeah. So you can, yes, you can run it on a Mac. Works about 90% of the functionality is there. But yes, it's primarily a Windows program, yeah.
Larry, one thing I would love to, if there's someone who can talk on this subject, so while I've got you, many of us suffer from major noise on the low bands and do our best to eliminate them, but still don't have much progress. But we love working top band. I understand there are a lot of new digital techniques now that will allow digital noise canceling that are really fancy, using maybe a sensing antenna and some other things. There's a simple thing from MFJ, but I'm talking about some stuff that's even more using high-speed computers that works, that are available to us in PCs nowadays, that solve a lot of these noise problems and so forth. I would really love to hear someone who knows something about that, because it seems like the only solution that I can have here to really help make quantum leaps in my receivability on top band here. And I would like to know more about where they are and how to implement them. Do you understand what I'm saying?
Yes, sir. Yes, sir. I don't have a solution off the top of my head, other than to say that just for starters, until we find that guru who has not only the answers, but can tell you where to get everything you need, it's very easy for us to get Martin Jew and or one of his engineers to come on and talk about how they deal with it and the principles. And if that's not acceptable, then maybe Tim Duffy or somebody like that knows some people who would be good avenues to come and speak with all of us. And some things that they've tried. I think that was the appeal to Kevin's presentation on vertical antennas. Is it was a story of things he had tried and places he had looked, the resources he had sought out, and that would be a really interesting presentation, I think, Bill. Good suggestion.
Well, Ralph was talking before we started. You could tell us how his 2,400 foot Beverages do.
Yeah, yeah. Let me see how many times that would go around my house. I could, if there's any induction value in a beverage, I could just wrap one around my house. And
Larry, I think Tim, is it N3QE? I can't remember. He's very active in CS.
yeah, Tim Stoppa.
I think he's the guy that I'd heard something about these digital techniques from, and he was talking about implementing some of them himself. It seems I saw it on the PBRC reflector or something like that. And then all of a sudden his power company solved his problem and he quit doing it. So maybe that's someone we need to look into, because apparently he was, you know, ahead of the power curve and looking into that kind of stuff. He might be a good source.
Wonderful. With the major culprit being like commercial power noise.
Yeah.
Right. Interfere. Okay.
My problem occurs, you know, I'm fine during the daytime, and then at night we have sodium vapor lights around here, street lights, and I've tried everything I can do, including to locate the one that's offending. And it may not be them, but it's awful strange, because it just happens right at sunset, you know, when those start popping on, that all of a sudden this impossible noise level comes up and so forth. And then in the morning, it disappears. So it's something that seems to be photoelectric triggered. Now, it may not be those, maybe something else that is photoelectric triggered, but I have not had any luck in tracing it and finding it where it is.
22 caliber rifle, Bill, with a good scope.
If I knew which one to shoot out.
Yeah, well, we, without telling a long story, we had quite an time around my house when I had like 20 dB over noise. And with the power company, it took about 3 days, but finally it took a transducer built out of the reflector on the headlamp of a large logging truck, and removing the bulb and putting in building a transducer with headphones that found it as a lightning arrestor that had no external faults. And in the process, we discovered about 6 different utility lines that had lightning strikes where there were weak points in there. It was creating dirty power, but it really helped but it took a long time. I mean, we built those, you know, those satellite receiver Yagi antennas with the tape measures and turn them vertically and horizontally. I have pictures of people standing on top of my house and pointing antennas everywhere. You couldn't find them even with the aircraft band receivers with attenuators on the receiver, on the antenna. The noise was just everywhere. Anyway, okay, that's a good suggestion. I'm feeling bad about Steve being up, and it's almost daylight over there in Norwich.
I'm going to go now and leave you to it. I think that's probably the best thing to do, because it's now
Thank you, Steve. Awesome job. Awesome job.
Thank
no
you
problem
so
at all.
much.
All right, I'm going to get some sleep.
Good job, buddy. Thank you.
Thank you.
No problem at all. All right,
thank you very much.
Well, I'll just
Thank
go
you,
ahead and
Steve.
end
Hi, Marks.
Thank you very much.
the recording here, and thank you very much, Steve. So